Welcome back to another Python interview practice problem. This one is sum root to leaf numbers. This is a binary tree problem where we're going to be using recursion. So let me just show you what we're going to do real quick. So we have this tree, and we need to get all the numbers from root to leaf, leaf being the last element on the tree. So and add them all together. So we need to get 495. So 495 will be the first number, 491 will be the second number, and then 40 will be the third number. And then we need to add those all together, and then we get our answer. And how are we going to do that? We're going to use a recursive algorithm. So let's see, we've got the tree here. I'll draw it again. 4, 9, 0, 5, 1. And so we're going to do, we're going to call a function, call it getSum, on our root, and so we're going to put our root in here, and then we're also going to pass in the current string. So we haven't added anything to it yet, so it's just going to be empty. And then we're going to pass in an array, but it's going to be a pointer to an array, so it'll be a variable. And that's what we're going to use to hold all of our numbers when we get to the leaf. When we get to the end of each path. So then what we're going to do is we're going to call this function on itself, but we're going to do it if we're only going to do it if we have a left or a right. But just for simplicity's sake, we'll say for now we do getSum on the left, and then we're going to add our current value 4 to the string. So this is going to be 4 now. And we're going to put our array in there. And then we're going to if I can, let me see if I can just move this over here so we get more space. So then, so we're going to do it on the left side, but then we're also going to do it on the right side. But since we have it defined to do the left side first, when it gets into the inner function, it's going to do the left side of the inner function before we get to the right side. So So before we come back and do the outer function, we got to do the where we're calling it on the left side in the inner function. So then we're going to go get some, again, the left side of this would be the left side of the root node, and then this would be the left side of this left side node. So always just like the left side of the node being passed in. And then we're going to pass in here 9. And give our array. So then when we get here, we're going to be on the leaf. We're going to be on 5 because we're doing the left side here, and it's the 5. And at that point, we're just going to add to the array $495. And then we're going to do the right side of the 9. So we're going to go get some right, because we've reached the leaf now. So now we can kind of come back and complete these function calls. Right, 9 array. And what's on the right side? Well, on the right side, we have 1. So we'll go array plus equals $491. So now we're done with the inner part of the for function here. So now we just need to do the right side of the root function, because we're back on that. Now we're back to that function. Get some right for oh, sorry, I did that weird there. Right for, and then the array. And then at that point, we're just going to add to the array 40, because that's another leaf here. 40. And then we're done. So this pointer to this array, we define the memory location to where that is when we first call this function, and then that doesn't change. We just keep passing it in. So So these numbers get added on to the array, regardless of what function call it's in, and then we have all of the root to tip numbers in our array at the end. And then at the end, it's pretty simple. At the end, what we just have to do is we need to cast those all to integers and then add them all to a result number. So let's implement it. So just like so we need to create the function that's going to call itself. So we'll create getSum. And then we're going to say if not current, then return. That's just to avoid errors if we have if we reach a null pointer for some reason. And then if current.left or current.right, we're going to say if, because theoretically we could have a tree where there's a left or a right branch, but not the other. We'll say if current.left getSum current.left string, and then we're gonna do string plus string current.value, and then we're gonna pass in our array. If current.right and call getSum on the right branch. I do string plus pass to string our oh, what did I do here? Pass to string the value and then the array. Cast a string current.value and then the array. And then but if there is not a left or a right, then that means that we're on the leaf. We're on the terminating branch, right? So then we'll say else, and that is when we add to the array the string plus the string representation of the current value. And that's it for the recursive function. Now for the function that starts the recursive call, we're gonna make the array pointer, and so once we've created this, it's that's just gonna stay the memory location of the array. It doesn't get remade when we pass it into to a function, because Python always passes arrays by reference. And then we're going to call getSum with an empty string to start with. and give it the root function. And then this is going to, this one function call is going to call everything that I just showed you in the pseudocode. The one function call is going to call the function calls within it, which are going to call the function calls within it until it reaches the terminating the end condition at the leaves. And at that point, our array is going to be fully populated. So we'll say result is 0, and then we'll say for number in array result plus equals, then we're going to cast to integer the number so that we can add them together like math numbers rather than concatenating strings. And then finally, we're going to return the result. And let's see how that works. All right. Well, thank you all for watching, and I'll see you next time.